whatever it is that of your OU previous question paper, just I list out in that unit wise. Unit 1, what are the short answers they will ask you, and long answer questions that previously it is asked already previously. So say if you are going to go through of your this one, you can get it that idea about how the questions are going to be framing and how that topics is going to be adding and what you need to write it like that. You can go through it once. Okay, this is for your first unit, and this is for second unit. Unit wise I separated. Maybe some questions they may repeat it, but some different ways they will ask you, right? Just go through of your this of your questions. Just I will post it in your class group. Okay. Then I already told you that I hope you know that. Okay, that COA is nothing but of your computer organization and architecture. If you go through of that syllabus, it is going to be coming to of your different of parts of your computer, how you're going to be designing. That is nothing but of a, not a computer, it is a processor we are going to be designing, right? So say if you're going to be designing a processor for that, right, what are the requirement, what are the different methodologies we having, that we are going to be studying in this subject. Okay, in this the first unit basically it is for your that particularly arithmetic operations. That means of your how we are going to be performing of your arithmetic operations, right? So that's why that is about of your we having of your representation, floating point representation and fixed point representation. So say what is the representation of your number, fixed point representation and floating point representation, and what are the different operations of arithmetic operations, that is for your addition, subtraction, multiplication, division for fixed point as well as floating point, right? Like that we are going to be having of it that algorithms, right, how it is going to be following, and what is that hardware blocks we are going to be having, that we are going to be studying in your first unit, right? And 2 3 4 5 is going to be coming off here, that particularly each of that one is for a one part. First second unit is for your control unit, basically the design of your control unit, that is for hardware control unit or micro program control unit, right? The design of your control unit again depends on of your instruction format, right? So what is the instruction format, how it is going to be instruction cycle it is going to be performed, right? So that like that you are going to be studying about of your that instruction cycle, that is about of your control unit explanation it is going to be given. And the third unit is for your that CPU, that it is going to be gives of your that central processing unit, how it is going to be designed, what are the different types of your central processing units methods we are going to be following, right? And we are going to be studied about of your parallel processing techniques we are going to be studying. And fourth unit is going to be IO organization, that input output devices, how it is going to be organized, that we are going to be studying of your fourth unit. And a fifth unit is for a memory organization, right? This is the basic idea. Just I hope already you remembered that. Just I'm going to be brushing what are the units we having, right? Just I'm going to be covering of that particular syllabus what is there once again, right? Then the choice of your my choice of your preparation is better to go for your fourth unit first, right? That means of your very easy, and it is having of your very limited topics. Those who are looking for your just for pass or whatever maybe that definite questions, what are the questions, most probably we are going to be getting off your 4 to 5 questions it is in this fourth unit. So that's why you are going to be getting off your that 4 to 5 questions only. From that questions only you're going to be regularly they will ask you that, right? So it is very small unit also. So first preparation, you can go for your already you know the subject, right? So just it is not required of your that much of your whatever it is of your previous units it is going to be required, right? So go for your fourth unit, that is for your IO organization, right? Are you listening?
Yes, sir.
Yeah. Studied anything about of your IO organization? Remembering anything? What we studied in that IO organization? ఏమన్నా తెలిసింటే చెప్పండి ఒకసారి. సో దిస్ వి స్టడీడ్. ఐ హోప్ నేనే చెప్పాను అనుకుంటా ఫోర్త్ నేను. అవునమ్మా, ఉన్నారా మర్చిపోయారా? తెలియకపోతే చదివలేదు సార్ చాలా రోజులు లేదని చెప్పండి. ఇంకా ఏదో అనకుండా కూర్చుంటే కష్టం. హలో, ఉన్నారా? It's 78.
Yes, sir.
No, ma.
Yes, sir.
చదివామన్నా?
Yes, sir. 15 minutes.
5th unit you're studying. Okay, okay, okay. Okay, 4th unit didn't study. Next, anyone? 83, 115.
No,
This.
sir. Fourth unit didn't study, sir.
Okay, okay. Which unit you are going?
First unit completed.
First unit completed. Next, 115. 115. Started any preparation? 115, are you there? Uh, um, Started any preparation? Mm. Which unit you studied? Second and third unit. Okay, good. Next, 310.
Yes, sir.
చదివామా ఏమన్నా?
Yes, sir. Second and third.
సెకండ్ అండ్ థర్డ్ సరే రేపు సెకండ్ అండ్ థర్డ్ చెప్పుకున్నాను నేను ఓకేనా ఓకే
Okay, sir.
వాట్ ఎవర్ ఇట్ మే బి జస్ట్ ద ఫోర్త్ యూనిట్ ఈజ్ వెరీ ఈజీ యాక్చువల్లీ సో దట్స్ జస్ట్ ఐ స్టార్టెడ్ విత్ that unit okay basically it is very simple unit and we having of your very less topics actually so that's why just I started with your fourth unit okay this is the fourth unit we are going to be having of your input output organization so say what are the input output devices we having that we are going to be input output devices we are going to be how we are going to be connecting to that processor and what are the steps what are the techniques we are going to be using in this basically IO interface is going to be required what is the requirement of your IO interfacing right this is the part we are going to be using for your IO interfacing right why we require of that one is for your peripherals you are going to be required for your converting of your electromechanical and electromagnetic devices and CPU memory or electronic devices that is going to be conversion of your signal values may be needed so let's say we require of your interfacing circuit in between of your IO devices and processor right what is the one point is conversion of your signal values that means of your electromechanical or electromagnetic devices some other devices is going to be sending of your different formats so say that conversion of your that signal is required so say we require of your some peripheral or interfacing circuit right then what is the data transfer rate of that one is going to be slower than of your whatever the CPU so say whatever the IO devices is going to be sending that is for your slow devices it is going to be sending the data so say that we require of your some of your synchronization is going to be required for that so say we are going to be device of your interface device is required another requirement is for your synchronization purpose right? And it is going to be having of a different formats data formats it is going to be coming so say different data formats is going to be using for your the devices so we need to convert of your that device formats we require of your interface right and next one is for your it is going to be used for your controlling of your not to disturb of your other peripheral devices right if you're going to be more than one or of your peripheral devices is going to be connecting which one we need to activate that particular device that is also we require of that so we are going to be using of your interface right so these are the four advantages or requirements why we are going to be using of your interfacing circuit in between of your IO devices and processor right just go through of your this 4 points one is for your conversion of your signal and one more is for your synchronization mechanism and it is going to be used for your different data formats and it is going to be using for your this not to disturb of your other device right and then we are going to be having of your this it is not required just I'm going to be telling of your uh, yeah exam point of view only right so we are going to be having of your asynchronous data transfer what are the asynchronous data transfer we are going to be having one is for your stroke control method and handshaking method right we are going to be having of your two methods of your data transfer between of your IO devices and that processor so that is for your one is for your what is that first one what is the first one yes what is the method
Strobe control.
Yes, strobe control, and one more is for your
Handshaking.
handshaking process, right? These two are the methods we are going to be using to transfer of your data between of your IO devices and CPU. So what is the strobe control? It is going to be having of your only two signals, right? One is for your data and one is for your strobe signal. Strobe signal is nothing but of your indication is giving to of your that the data is available in the database, right? That is going to be intimation is going to be sent through of your strobe signal, right? So it is going to be having of your two signals of your strobe signals, that is for your data bus, and one more is for your strobe, right? So we are going to be having of your two again, source initiation and destination initiation, right? So which one is going to be initiated first, that we are going to be taking first. So this is for your source initiated strobe for data transfer, right? So it is going to be having of your source unit, and this is for your destination unit. Just we are going to be placing of your data on the data bus, and which one is going to be initiating first? Source initiated, right? So say that it is going to be strobe signal is going to be coming from your source unit. It is going to be generating of your the signal, right? So what is the timing diagram? First we need to place the data on the database. So this is your starting point. That means of your first it is going to be activated by the data is on the database, right? After some time, then you are going to be data is placed on the database, we are going to be activating of your strobe signal, right? So this is for your source initiated of your strobe control signal, right? We are having of your two signals, and then we having of your here the destination. So say we are going to be having of your source unit and destination unit. The data is always it is going from your source to destination, right? But the strobe signal is here. What is that one? It is going to be destination unit is going to be asking of you the data. So it is going to be calling as your destination initiated strobe for data transfer. That means of your who is asking the data, it is going to be asking of you the data by destination unit, right? So say the direction you can see here, it is the strobe signal direction is going to be coming from your destination to source, right? So say source is destination is asking I need some data of this one, right? So that it is going to be activated that. So say it is going to be first activating of your the strobe signal. Sorry, this is the later wrong one, right? Actually this is your strobe, this is your data, right? So first it is going to be strobe signal is going to be activated, then it is going to be data signal is going to be placed on the data on the database, and it is going to be activates, right? So that's why this is for your destination initiated. The data is going to be placing the data in the database after receiving of your request from the destination unit, right? So say first it is going to be initiating who will take off your initiation destination unit, right? So destination unit first it is going to be activates of your strobe. So just you can reverse of this one. This is your data comes down and the strobe is going to be comes up, right? So this is for your strobe signal, right? First it is going to be activated, and then it is going to be data signal. It is going to be activated after you are receiving of your request from the destination. The data is going to be placing on the database. Previously that it is going to be first we are going to placing of your the data on the database, and then you are going to be strobe signal is going to be activating, right? Now it is for your first we need to receive of your strobe signal, then only we are going to placing of the data on the database, right? So this is for your destination initiation in the strobe model, right? So that is for your strobe signals we are going to be having, that it is going to be two signals, data bus and strobe. In this we are going to be having of your source initiated strobe signal and that destination initiated strobe process, right? So this is are your two of your methods we are going to be using for your strobe method. And what is the disadvantage of your strobe is that it is not going to be having of your any acknowledgement that data is received by destination or not, right? So we are going to be sending of the data from source to destination. Once if how it is knows that source unit the data is received by destination unit or not, right? So that is the disadvantage in your strobe method. So we are going for your next one is for your handshaking process, right? So handshaking process is going to be having of your three of your control signals. One is for your data bus, data valid, and data accepted, right? So these are the three signals. So data bus is going to be placed on the data, and data valid is going to be once the data is placed on the data bus, we are going to be validating of it the data. So it is going to be data valid is going to be activated, then it is going to be data accepted, that means of your received by destination unit, that signal is going to be sent by your destination unit, right? So this is the process of your three control signals that is called it as your handshaking process, right? So the handshaking process is going to be having of your acknowledgement of your the data it is received to the destination unit or not, right? That is going to be sent through of your data accepted or data it is going to be requesting, right? So this is the three signals we are going to be using, right? So which one is going to be, again it is going to be having of your source initiated and destination initiated, right? So it is going to be source initiated. Why? Because data valid signal data bus is placed, and then it is going to be data valid signal is going from your source to destination. So data is placed, then data valid signal is going to be activated by your source unit only. Source unit 2, it is going to be sending to of your destination unit. So you can see here the direction is from your source unit to destination unit data valid signal. Then it is going to be destination to of your source unit, that is for your data accepted, right? So this is the process. It is going to be there for this of your handshaking of the signals. Then it is going to be source initiated. So what are the sequence of events? You have to write that this is the block diagram and a sequence of events, and you have to write it off your timing diagrams also, right? So timing diagrams, just you can go through it once, right? The timing diagrams like this of your previously whatever we discussed, right? Like this, it is going to be there of a timing diagram. Timing diagram also you have to write it, right? So it is going to be source unit is nothing but of your place the data on the data bus, enable data valid. So first source unit is going to be place the data on the data bus, and it is going to be enable of your data valid signal. Then it is going to be accept data from bus, enable of a data accepted. Data is accepted and okay, enable signal now. Then disable data valid signal and invalidate data on the bus, right? So say like that, it is going to be invalidate of your that one once it is receiving of that one, right? So this is we are going to acknowledgement through of your this data accepted signal. Disable of a data accepted, ready to accept of it the data new, right? So like that, it is going to be receiving of your acknowledgement of your the data is received or not, right? Like that, it is going to be there of your source initiated handshaking process. Then they are going to be having of your destination initiation. So the destination is going to be first request, it is going to be asked. So say ready for data, I am ready to receive the data first. It is going to be sending of your information from your destination to of your source unit. Then only it is going to place the data on the data bus. Then it is going to be validate of your the data bus. So it is going to be initiated by your destination unit, right? So it is going to be ready to accept data, enable ready for data. That is going to be taking off with the ready for data. It is going to be taking, and it is going to be place the data on the data bus of your data validate, and then it is going to be accept data from your data bus. It is going to be ready for data. Then it is going to be disable of that one. Then it is going to be waiting for your ready to accept of your the data, right? So like this is going to be taking off your source or destination initiated of your handshaking process, right? So this is the one of the important question they will ask you. So say data transfer, how it is going to be done, or it is going to be directly they will ask you for your strobe method and handshaking process of that one with your source initiated or destination initiated, right? Just we'll see of you the questions once again. The questions what they ask you in the fourth unit. Yeah, difference between of your synchronous and asynchronous data transfer. What is the synchronous and asynchronous data transfer? Can anybody? What is synchronous, asynchronous? అరే ఉన్నారా ఉన్నారమ్మా హలో am I audible? అరే వస్తే వస్తుందని చెప్పు, రాదంటే రాలేదు సార్ తెలియదు సార్ అని అడిగి చెప్పండి. కానీ అలా ఊకి మత్సంగా కూర్చుంటే మాత్రం నాకు సంబంధం లేదు. క్లోజ్ చేసేయమంటే క్లోజ్ చేసేస్తా. Hello.
Yes, sir.
Yes, tell me what is that synchronous, asynchronous?
Memory, sir. It has.
Okay. Still మీకు తెలియకపోతే నేను చెప్తాను కదా, మీరు చెప్పండి ఫస్ట్.
Acknowledgement.
ఓకే. సింక్రనస్ అసింక్రనస్ అమ్మా ఎస్టీఎల్ లో కూడా వచ్చి ఉంటుంది మనకు, సింక్రనస్ డివైజెస్ అండ్ అసింక్రనస్ డివైజెస్, right? Whatever it is there of your synchronous devices, it is going to be having of your same clock frequency, right? So that is called it as a synchronous. So that's all the devices operated in the same clock, right? That is called it as the synchronous. Asynchronous is nothing but of your that all the devices the devices is going to be operated for a different clock of your uh, uh, devices, right? So say that each device is having of a different clock, so say that operate on that particular clock only, right? So that is called it as a asynchronous. So say for your synchronous, if it is going to be operate of your the both devices in the same of time, so say it is not required of your any data of your this format. If it is for your that particular asynchronous, that means of the two devices are not to be in synchronous mode. So say that both are not operating in the same clock. So say then it is going to be required of your some format we are going to be placing. That is called it as a asynchronous data transfer. That is going to be having of your start to stop that we'll discuss in the next one. So say like that it's going to be there. Then yeah, you can see here what is the need of your IO interface. Yes, what is an interface? What is the need for IO interface? అరే ఉన్నారా లేదా అరే
Yes, sir.
IO interface need చదివాం కమ్మా.
ఇన్ఫర్మేషన్ పాస్ చేయడానికి సార్ ఇన్పుట్ నుంచి ప్రాసెసర్కి.
ఓకే, స్టిల్ చెప్తున్నాను అలా రాస్తే మాత్రం మార్కులు వేయరు. ఐఎమ్ టెలింగ్ యూ రైట్. ఐ ఆల్రెడీ టోల్ దిస్ ఈస్ ఫర్ యువర్ నీడ్ ఫర్ యువర్ వాట్ ఆర్ ద రిక్వైర్మెంట్ ఆఫ్ ఎ పెరిఫెరల్ డివైస్, right? So why it is required is this one is for your conversion of your signal values, right? One more is for your synchronization mechanism, and we are going to be required for a different formats, and next one is for a not to disturb of your other operations, right? This is the question they will ask you, right? That is for your what is the need of your IO interface, right? Why it is going to be needed for your IO interfacing circuit, right? The again it is going to be same compare and contrast between of your synchronous and asynchronous communication, right? What is the contrast between of your synchronous and asynchronous communication? Yes, yes sir, these are the questions for your previously it is asked, and it is the same question of your first question, difference between of your synchronous and asynchronous data. Just now I told you what is a synchronous, what is asynchronous, what are the difference between of your synchronous and asynchronous data transfer. Hey, ఏమైందిరా? Hello, hello, are you there? హలో, ఉన్నారమ్మా? అరే ఇది మీకోసమేరా క్లాసు. మీరు కూర్చొని నేను చెప్పుకుంటూ నేను పోడుకుంటే ఎందుకు? హలో,
ఎస్ సార్, ఎస్ సార్.
చెప్పండి రా. ఏం రా నేను ప్రీవియస్ క్వశ్చన్ పేపర్లు కూడా పెట్టేసి చెప్తుంటే ఇంకేందిరా? ఆ యూనిట్లకి ఎలాంటి క్వశ్చన్స్ వస్తాయో కూడా చెప్తున్నాను నేను. ఇంకేం కావాలరా? This is for your one the same question. What is the need for IO interface? Explain the functions of a typical 8-bit parallel interface in detail. Right? So say 8-bit of your detail 8-bit of your interfacing function అని ఒకసారి ఎక్స్ప్లెయిన్ చేయమని చెప్తున్నాడు. అండ్ ఇక్కడ మనం మెయిన్గా వచ్చింది దేని గురించి draw the flowchart of your destination initiated transfer using of your handshaking model, right? So say like this they will ask you the question, the flowchart of your that particularly destination initiated, particularly he mentioned that destination initiated of your using of your handshaking process, right? So that is going to be explain of your this destination initiation of your handshaking process. So this is for your source initiation and destination initiation handshaking process. Yeah, this is for your destination initiated of your handshaking process. You have to explain of your this destination initiated of your handshaking process with that. Okay. Yeah. Explain asynchronous data transfer using of your strobe and handshaking process, right? So you have to explain of your strobe, source initiated strobe and destination initiated strobe. In the same way, handshaking, it is going to be having of your source and destination, and it is going to be strobe is having of your two signals, and handshaking is going to be having of your three control signals, right? So you have to explain of your that particular one. Okay, like that, it is going to be asked about of your source initiated and destination initiated. So this is just to go through of your this one. It is very simple one. And whatever it is there of your IO interface, I already told you this is for your why it is going to be needed, right? Need of your IO interface, right? One is for your conversion of your signal, and it is going to be used for your synchronization, and it is going to be using for your different data formats conversion, and it is going to be used for your not to disturb of your other devices, right? Then we are going for your what is the format it is going to be used for your asynchronous. Yes, so this is for asynchronous serial transmission that is going to be having of your different clock of your devices that the different devices is going to be operating of your different clocks, right? So it is going to be not to having of your both in not in your same of your clock signal. So ఇది ఎంత స్పీడ్ లో పంపిస్తుందో అది అంత స్పీడ్ లో తీసుకోలేకపోతుంది. So we need of your some of your intimation control signals we need to send to that is going to be having of your that format is divided into of your three three categories or three blocks. One is for a start bit, right? And one more is for your character bits or message bits, and next one is for your stop bits, right? So this is the format you have to mention. So first it is always it starts with your start bit. So say that destination need to understand that okay, that I'm going to be receiving of your that next of your coming bits are your my message bits or character bits. So that's why that it is going to be indicating as a start bit is always it is going to be zero, right? So once it is received zero, the next bit onwards it is going to be considered as your message bits or character bits. So it is going to be taking off your next coming of your bits are your message bits, and then it is going to be stop bit here. The stop bit is going to be always one, right? So it is going to be once it is going to be over of your that particular asynchronous data transfer of your 8 bits, then it is going to be placing of your active high signal, that is call it as your stop bit. It is going to be X, right? This is the format we need to follow of your that particular asynchronous data transfer, right? So this only it is asked for your that what is the data format of your asynchronous data transfer. um, yes, data transfer, asynchronous data transfer format is going to be mentioned that one format, and you can write it as a synchronous asynchronous differences in between that, right? So that is for your asynchronous data format, right? Then it's not required. Okay, then you go for your modes of transfer, right? We are going to be having of your two different types of your modes. One is for your synchronous mode and asynchronous data transfer mode. In that, it is going to be having of your three different ways. One is for a programmed IO, interrupt initiated IO, direct memory access, right? These are the three different methods we are going to be using to data transfer modes, right? What are the data transfer modes? What are the data transfer modes? What are the data transfer modes? Am I audible?
Yes, sir. Asynchronize, synchronize.
Synchronous, asynchronous. In that, we are going to be having of these three methods. You have to write it: programmed IO, interrupt initiated IO, and
Direct memory.
direct memory access. Right? These are the three of your data transfer methods we are going to be using. Right? So these are the three methods we are going to be using for your data transfer. and programmed IO, interrupt initiated IO, and direct memory access, right? So a programmed IO is nothing but of here how it is going to be programmed, whatever the program it is going to be written, that like that it is going to be executed, right? So it is going to be having of your CPU. Example, we need to explain with this one. We're having of your one CPU here, right? We are going to be having of your IO devices here, right? So we are going to be connecting of your CPU with your IO devices. We require of your some interfacing circuit. So this interfacing circuit is going to be having of your data register, right? It is going to be holds of your the data in between of your CPU to IO devices or IO to CPU to whatever the data you're going to be transferring. That is going to be holding in this particular data register and just transferring into of your that particular CPU or IO device. And then we are going to be having of your status register. In this, we are going to be having of your one F, that is for your flag bit, right? So like that, it is going to be having of your interfacing, and this interfacing and IO is going to be connecting like as your handshaking process. IO bus, data bus is nothing but of your IO bus. The data is going to be validate, and then once it is received by interfacing circuit, then it is going to be data is going to be accepted signal is going to be placed, right? So what is that it is going to be there? It is going to be the data is transferring from your IO devices to of your memory, or through of your memory through of your CPU, it is going to be transferred into of your memory. So it is going to be the data is going to be collecting from your IO devices and placed in the data register, and the data register too, it is going to be taking into of your data bus, it is going to be collected to CPU, and that is going to be operation is going to be selecting through of your IO read or IO write and address bus, right? Like this, it is going to be having of your the different of your signals to connect of your CPU to IO interface. So this is that interfacing circuit of your CPU to interfacing. The signals are data bus, address bus, IO read, IO write. That are the control signals of your IO read and IO write. And we are going to be having of your interface and IO devices is going to be connecting through of your handshaking process. Right? That is for the IO bus, data valid and data accepted. Right? Like these are the signals that it is going to be connecting of your that programmed IO. Then coming to of your process, how it is going to be there, then the data is going to be transferring from your IO devices to of your memory through of your CPU. The data is going to be collecting from your IO devices and placed in the data register, right? Then it is going to be flag is going to be set to be one. Once the flag is set to be one, that it is going to be collected by your CPU from your data register, right? So like that, it is going to the process is going to be continuously it is going to be done, right? So what is the disadvantage in this one of your programmed IO is that CPU is going to be continuously monitoring of it, the flag bit, right? So when it is going to be flag bit is going to be set to be what, once the data is going to be received from your IO devices to of your data register is full, then it is going to be flag bit is going to be set one. So that it is going to be once the CPU is going to be confirmed that flag is bit one, then it is going to be the data register data is going to be moved to of your that particularly memory or whatever the operation is required by your CPU. Right. So that is the process it is going to be done. Right. So what is the disadvantage in this one is for you? The CPU is going to be wasting of your time to monitoring of your flag bit instead of your to do of your some other works, right? So that is for you the particularly the disadvantage of your programmed IO. The programmed IO, it is going to be disadvantage is for your the data is going to be transferring from your IO devices to of your that interface. The data register is going to be once full, the flag bit is going to be set one. So that CPU is going to be monitor of your the flag bit always instead of your doing of your other ones, right? So this is for your disadvantage of your programmed IO, right? So to overcome of your this one, we are going for your interrupt initiated IO. Interrupt initiated IO is going to be taking off your that whenever the data is taken by of your interface, right? So the flag bit is one, then we are going to be sending a interrupt signal to of your CPU. I already collected of the data into of your data register. So you can collect of the data. So until that time, the CPU is going to be busy with his works, right? So that is for your that particularly interrupt initiated IO. So interrupt initiated IO is going to be it is going to be overcoming of your programmed IO of your method, that is nothing but of your we are going to be not to monitor of your the flag bit, right? Instead of your that once it is completed, then we are going to be sending of your request signal to of your that particularly interrupt signal is going to be sending to CPU, right? The data is going to be collected, right? Like that, it is going to be interrupt is going to be initiated from your interface, right? So that is for your advantage of your interrupt initiated IO, right? So that is for your, the process is same for your programmed IO, just only changes for your interrupt is going to be sending to that particularly to CPU, right? That is called it as an interrupt initiated IO, right? So what are the methods it is going to be coming off here, that different interrupts, right? So vectored interrupts and non-vectored interrupts, right? Then we are going to have of here priority interrupt and polling process, right? So we are going to be different methods how we are going to be solving of your that interrupts. If you are going to be having of your more than one of your interrupts, right? Then what is the procedure it is going to be following, right? That is for your polling method, and that it is going to be priority method, right? Then next one is for your daisy chaining priority. Daisy chain priority is nothing but of your daisy chain priority is going to be having of your the devices of your connecting from your high to low, that priorities based on that of your highest priority device to of your lowest priority devices, and we are going to be connecting that particular all the devices with the same of your interrupt signal of your CPU, right? So say once the interrupt is going to be generated, that is going to be sending of your interrupt signal to of your CPU. Once the interrupt is generated, the CPU is going to be acknowledges to that particular devices. So it's the highest priority device, whichever it is going to be first we having, that it is going to be use of your acknowledgement, it is going to be received, right? So it is going to be, once it is going to be request is sent device one, then it is going to be service is going to be given. Otherwise it is not going to be given send request signal to of a device 2, like that it is going to be highest priority lowest priority devices is going to be there. So say once it is done, then it is going to be uh, forward to of your next devices, right? Like that it is going to be daisy chain priority process is going to be done. Then we are going to be having of a parallel priority. The priorities we are going to be giving to of a parallel way. So we are going to be having of your four of your devices connecting to of your parallelly, and we can use of your mask register to mask that particular interrupt, that is nothing but of your enable or disable of your okay. Okay, that is for your that particularly priority parallel priority of your this one. So the parallel priority is going to be taking of your priority encoder, it is going to be using to generate of your highest priority device to of your that particular valid address, right? So this is for your parallel priority method. Interrupt register it is going to be there, and we are going to be using of your mask register to enable or disable of your that particular devices of your whatever the IO device, right? So this way it is going to be generating of a priority to that particular one, right? So this is for your priority register. And next we are having of your another method is for your DMA. DMA is for your direct memory access, right? This is for your three different methods of your data transfers. One is for a programmed IO, interrupt initiated. Interrupt initiated again we are going to be having of your polling process, that is like as a daisy chain, and whatever it is of your parallel priority, that is nothing but of your from priority encoder, right? That is going to be performed with a parallel priority interrupt. This is for your two interrupt initiated, right? Then we're having of your another one is for your DMA. DMA is for your direct memory access. So say to wasting of your the time of your CPU, just a transferring of your data from your IO devices to memory. Instead of your that, we are going to placing of your some other processor, DMA processor or DMA controller, right? Then we are going to be take care of your that particular data transfer between of your memory and IO device, right? That is called it as a DMA of your operation, right? So the DMA is going to be direct memory access we are going to be using. In this we are going to be having of your control signals. One is for a bus request and one more is for your bus grant signal, right? So it's a request signal and grant signal, it is going to be there, and hold that means of your hold signal. Okay, this is for your whatever it is of your DMA. DMA is going to be having of your bus request is going to be coming, and bus grant signal is going to be sending out read write control signal data bus address bus, right? Then it is going to be right. This is for your DMA control. One more, it is the diagram for this of your interfacing circuit. Just to go through of that particular diagram of your DMA, right? Just it is going to be having of your DMA controller, and we are going to be having of your IO devices, and we are going to be having of your memory and CPU. right? So the four devices, how it is going to be switching is going to be done between of your that devices, right? So first it is going to be received of your bus request from your IO device. Sorry, IO devices is going to be asked for your IO read or IO write operations from that IO devices. Then the DMA is going to be receiving that once the request signal is going to be sent to of your bus request to CPU. The CPU is going to be grants of your bus permissions. Then it is going to be data transfer from your memory to of your IO device. Then once it is done, then it is going to be it is going to be released through of your interrupt. It is going to be generated, right? So say like that, it is going to be the process is going to be done. That is for your DMA transfer, right? These are the three different types of your modes of transfer. What are the three different types of your modes of transfer?
Programmed IO, interrupted initiated IO,
DMA.
direct memory.
DMA. Okay, okay. See here the question, why, how it is going to, why does DMA have a priority over CPU when both request a memory transfer? Why it is going to be there? Yes, DMA advantage is only itself. It is going to be not to waste of your CPU time, right? So, say direct memory access, it is just transferring of your the data from your IO devices to memory. So, say it is going to be powerful of your device of your CPU. It is wasting just a transferring of your exchanging of your, the data from your IO to memory. So that's why only it is going to be introducing of your DMA, right? So the DMA is going to be taking of your that transfer of your data of your from IO to memory so that the CPU is going to be free and it is going to be work on for your other works, right? So that is the advantage of your DMA, right? Then it is going to be yeah. What is interrupt driven IO? What is interrupt driven IO? Interrupt driven IO is nothing but of your interrupt initiated IO. What is an interrupt initiated IO? This interrupt initiated IO is nothing but of your, it is going to be taking off your interrupt instead of your observing of your flag in that programmed IO of your CPU, right? So say it is going to be wasting of your time of your CPU. So say we are going to be instead of your watching of that flag bit, just we are going to be sending a interrupt signal once it is going to be receive the data from your IO devices. So that's why it is going to be interrupt initiated IO. It is going to be generating of your interrupt, right? Not to watch of your instead of your watching or monitoring of your the flag bit in your program IO, right? So that is for your interrupt initiated IO. Various data transfer methods. What are the mention the various data modes of transfers? Programmed IO, interrupt initiated IO, and DMA. Yes, you can see here that explain daisy chain interrupt and design parallel priority. Next one is for your handshaking control. I think them giving isolated versus need of difference between memory and short answers. Daisy chain again, then DMA, again DMA, again daisy chain, again DMA. Right, you can see here that are the different ways the questions they will ask you: DMA or programmed IO or interrupt initiated IO, right? Like this they will ask you. So many questions are there in this, right? And the next one is for your the topic, I think, CPU IOP communication. Just a minute. Yes, just go through of these three methods. We are going to be studying about that particularly. DMA, and programmed IO and interpret IO. This modes of transfer, right? So that most probably you are going to be getting off the question from your these three methods only, right? Okay, so the programmed IO, interpret IO, you are going to be having of a daisy chain and parallel priority, and one more is for your DMA, right? So these are the three questions generally they will ask you. And the block diagram of your DMA, just already I said that it is going to be having of your IO devices. So that's why IO devices is going to be sending of your DMA request. Once it is received of your request, it is going to be ask of your DMA to that bus request signal. It is going to be asking to the CPU. Once the permission is given, then bus grant signal is going to be received by of your the DMA. Once it is received of your bus grant signal, the data is going to be transferred from your IO devices to of your that particular memory. Then once it is completed, interrupt signal is going to be generated and given to of a bus request signal to of buses to of your CPU, right? So these are the read write control signal, register select, DMA select, and the data bus buffer, address bus buffer, where we need to take the data. So that is going to be hold in the data address register. How many memory locations, that is going to be word count register, and control register is for your we are having of your read write control, like that is going to be having of your control register, right? This is for your block diagram of your DMA. Then we are going to be having of your CPU IOP processor. Sorry, CPU IOP processors, right? That is the mode of your that we are going to be using of your instead of your DMA. DMA is going to be again control with your processor, right? Instead of that, we are going to be having of a separate processor. We are going to be designing for that particular operation of your IO transfers, right? So that is called it as your IO processors. IO processors, it will take care of your all of your input output devices or peripherals, the data transfer between of your that particular IO devices and memory unit. So IO processor is going to be having of your some of your instructions handling of that one. So it is going to be taken by take care of your IO process. So it is going to be not to depend on of your CPU, right? So it is going to be having of your the memory unit is going to be sharing from your CPU as well as your IO processors is going to be sharing this particular memory, right? That is for your CPU IOP communication. That is going to be starts with your CPU. What is that one? Send instructions to the text to the IOP path. So the IO processor, it is going to be sending of your information to CPU, that it is going to be having of your IO instructions. So that's why you can take care of that, right? So that is going to be received by of your IO operation. Transfer status word out to memory location. So I said that what is the status of your IO processor, what it is going to be doing now, right? So that is going to be placed in the memory location. So I said that it is going to be checks if it is okay. Start IO instructions to IOP process. So if it is for your free the status, then it is going to be sending of the particularly IO instructions. So that's the access of your memory from IO program. IOP program is going to be running this side and CPU is going to be running this side. So say CPU continue with your another program, it is going to be continuing parallel, it is doing with IO operations, right? So say conduct of your IO transfers using of your DMA, prepare of your status report, right? So once it is going to be done, then IO transfer completed, interrupt of your CPU interrupt gestion. Then it is going to status, it will ask you, then place of your the status in the memory location, and it is going to be check that particular status in that particular of your memory location of your CPU. And so like that, it is going to be checking of your the status of your that one using of your this particularly CPU IOP communication, right? Like that is going to be done with your CPU IOP communication. Very simple. It is like as your DMA only, but it is going to be having of your processor itself, right? Instead of your DMA, it is going to be total control with your CPU only. So that's why the CPU, it will take off your the control request. We need to ask bus request and bus grant signals, then only to transfer. But here it is not to be like that. The memory is going to be sharing with that particular CPU as well as your this IOP process. So this IOP processor is going to be take care of your all the IO peripherals. So it is going to be having of your own instruction set. It is going to be handled with that particular IO device, right? That is for your IOP process, right? So this is for your another important question in that fourth unit, CPU IOP communication. Explain of your CPU IOP communication. Explain CPU IOP communication. Write short notes of your CPU IOP communication, right? Like that, it is going to be having of your CPU IOP write short notes on of your IOP process. Right? So it's a input output process. Like that, we are going to be having of your DMA, that CPU IOP communication. Right? So this is the fourth unit. Generally, we are going to be having of your, these are the topics only. So I said just I will tell you only five questions, 5 to 6 questions only. It is going to be there. The remaining questions, the regularly they will ask you only for your modes of transfers. That is for your programmed IO, interrupt initiated IO, instead of in that interrupt initiated IO, daisy chain, parallel priority, and one more data transfer is for a DM, right? So these are the four questions, and CPU IOP communication, right? And that is for your another question, and we are going to be having of your one more source initiated and destination initiated of your IO. Right? So this is for your methods. What are the programs generally, they regularly they will ask you for your this fourth unit, right? So fourth unit is very simple and very less topics, right? So you can finish it up this one with your very fast, right? If you're having of your any doubts in this one, just you can ask me. I will clear off that particular one. Just go through of your fourth unit once today, right? That next class we'll see of your what are the doubts in that fourth unit, and then we'll go for your another unit of your fourth unit. Are you clear?
Yes, sir.
Are you listening?
Yes, sir. Yes.
I think it is useful for you only, right? So we are going to be conducting this classes because of you only. Okay, just we want you may forgot of you that particular subject after long time. So just